You're watching a Hanford Communities Issue Briefing, highlighting important environmental cleanup issues at the U.S. Department of Energy's Hanford site in southeastern Washington, issues affecting citizens of the Pacific Northwest and the nation. The Hanford Communities Organization was established in 1994 and is comprised of the communities surrounding the Hanford site, forming one voice to advise the Department of Energy on important transition and cleanup issues.
Welcome to another Hanford Communities Issue Briefing. U.S. Department of Energy contractor CH2M Hill Plateau Remediation Company is developing, testing, and deploying remotely operated tools to safely remove highly contaminated soil and debris from beneath the 324 building on the Hanford site. Workers will use remote operated equipment to access an area below the building and remove flooring, excavate the contaminated soil and debris, and safely package it for disposition. Due to its proximity to the Columbia River and City of Richland, remediation of the 324 building remains a high priority for DOE, regulators, and stakeholders.
All right, so what we have coming up is a short video that gives a very good overview of our safe approach to accomplishing this very challenging project.
The U.S. Department of Energy, DOE, and contractor CH2M Hill Plateau Remediation Company, CHPRC, are reducing risks in the 300 area of the Hanford site in Washington State. The 300 area is located along the Columbia River, just north of the City of Richland. This area supported the site's nuclear weapons production. Workers have demolished many of the contaminated buildings and cleaned up much of the contaminated soil that had resulted from work conducted in the 300 area. DOE and CHPRC are now addressing the challenge of removing highly radioactive soil discovered beneath one of the buildings during demolition. Crews at the 324 building are preparing to remove the highly contaminated soil below the building using only remote-operated equipment, cameras, and lights to guide operators. A team of well-trained personnel will accomplish this complex work using the lessons learned from the training and proficiency they gained on the equipment at a non-radiological, full-scale mock-up. The 324 building is divided into an airlock that connects 4 hot cells, including A, B, C, and D, with C cell located beneath D cell. The contamination is under B cell. Engineers developed specialized tooling and remote-operated equipment for use in that highly radioactive environment. CHPRC will augment the B cell foundation to ensure the excavation of the soil underneath does not affect the structural integrity of B cell. Workers will conduct excavation using remote excavators, which will hammer, cut, and dig out the floor of B cell to access the highly radioactive soil beneath. A specially designed, removable airlock rail and cart system will transport items in and out of the airlock. Crews will use existing facility cranes to install the equipment. The remote excavators will use several interchangeable tools to remove grout and debris, score and remove the existing floor, and excavate the soil underneath. Waste determined to meet the requirements for safe transportation and disposition can be shipped to the Environmental Restoration Disposal Facility located at the center of the Hanford site, which will ensure the protection of the public and the environment. Workers will stage the remaining radioactive waste from B cell in the surrounding cells and grout it in place. Workers will break up the existing 6-inch grout cap in B cell using a remote-operated hammer tool. Crews will remotely remove the remaining debris and transfer it to A cell. Following grout and debris removal, workers will cut the B cell floor's stainless steel liner and score the 6-inch thick concrete floor into segments for breakup and removal using an engineered remote-operated floor saw system. Workers will transfer floor segments from B cell to A cell, and later encapsulate it in grout to provide radiation shielding and contamination containment. Crews will use a second remote excavator for soil excavation, which will work in tandem to load waste bins that will be transported into the airlock using an engineered transfer mechanism. They will also excavate the highly contaminated soil beneath the B-cell footing to ensure that all highly contaminated soil is removed. When removing the soil, workers will target the most highly radioactive materials found around the perimeter underneath the former B-cell floor. Once they remove the highly contaminated soil, they will stabilize the excavated area, preparing the 324 building for future demolition. Removal of the highly contaminated soil beneath the 324 building will stabilize the facility and protect the Columbia River, reducing the risk to human health and the environment and taking one more step towards cleanup of the Hanford site.
My name is Ben Vanna. I work for the U.S. Department of Energy, and today I'll be talking about the 324 building. 324 building is located in the 300 area of the Hanford site, and that building was built in 1966. It operated through 1996, had a history of research on nuclear materials and fuel fabrication. In 1986, there was an experiment going on, and there was a concentrated cesium-strontium mixture that was dropped, fell onto the floor of the facility, and it likely ate through the stainless steel liner. So when we talk about the waste site, that is the type of waste that we're dealing with in the soil below the facility. B-cell, that is pictured in the bottom right-hand corner in the green, and that's going to be our focus in today's presentation, B-cell and the waste beneath it. This is a side view cross-section of B-cell. The blue is the 5-foot thick reinforced concrete walls, and there's also some debris and grout in the cell that we need to get through to the pictured in pink contamination below it. It's primarily cesium-strontium. In 2010, we sent in, or we put through the bottom of the facility 16 geoprobes, which gave us a contaminant profile below the facility. And the highest points are about 10,000 R per hour. And that goes down to about 6 to 8 feet. And in the videos you saw, the plan is to go in there, remove the floor, and remotely excavate below the facility to remove the contamination. And we believe that contamination goes down to about 6 to 8 feet for the remote excavation portion. Once we get past that, we'll be able to do typical open air demolition. And our equipment goes down to 12 feet. And pink goes down to roughly 6 to 8 feet. So we believe we have some extra conservatism here in case the contamination goes farther or we want to chase it further for extra removal. Some of the waste streams that we'll be dealing with in the facility, I've listed those in the left-hand side of the table. There's loose debris from A cell and B cell that we'll be removing. That's one of the waste streams we'll be generating. In the picture in the bottom right, you can see the old equipment in the cell and the grout. Some of that equipment was previously used, came off the walls, has been dropped there. Other equipment is purely from the grouting campaign to fix the contamination to the bottom of the hot cell. We need to remove all that so that we can get to the stainless steel liner in the bottom of the cell and cut through it. That stainless steel liner in the floor will be removed, and that'll be a waste stream itself, mixed low-level waste. Once we do get to the soil below the facility, that itself is low-level waste. And we mentioned some of the soil will be going into the hot cells. That'll be low-level waste also. And there's been some question, where is this waste going? We'll be sending it to ERDF. Some of the waste will have to go into the cells first before it goes to ERDF, because before we can send the soil to ERDF, some of it needs to be shielded appropriately, and that can be shielded in the waste containers. If we put grout, or in some cases stainless or steel liners into there, and that's to protect the workers and meet transportation requirements and ERDF's waste acceptance criteria requirements. And then the monoliths themselves, that's the waste that's going into the surrounding hot cells. It will be grouted into those, and we'll be moving those hot cells as monoliths, large concrete blocks, and those will be sent to ERDF. Then talking about the mock-up for this project, just due to the high radiation levels in the hot cell, we mocked up B cell. This is a full-scale mock-up that we did so that we can test all of our procedures at the mock-up before trying it in a contaminated environment. That reduces risk for the workers and increases the chance for success for the project. The picture in the left, we've got all of the equipment installed in the mock-up right now, with the exception of the floor saw, and the workers are actively training on using that equipment. And they also train on installing that equipment at the mock-up before they ever try it in 324. It helps us identify if there's any issues that need to be resolved first or opportunities for improvement that can be built into the work packages. It's all about keeping workers safe and getting the work done efficiently, spending less time in the zone where there's dose. Picture on the right, that is the remote excavator arm putting a soil bin into the transfer mechanism. And all of this work is done. You can't have workers in there in the hot cell just due to the high dose rate, so we have cameras providing multiple viewing angles for the workers, and it's almost like a video game for them. They have a joystick, they're moving the excavator arms around, moving the cameras around to get the appropriate viewing angles, and they pick up the soil bins, excavate the soil, and move it around. One of the difficulties is they don't have the same tactile feedback as if they were operating a heavy piece of heavy machinery in the field. When you do that, you can feel if there's resistance. Here, the workers have to be very proficient in understanding how much pressure they're putting on the equipment, so there's a lot of training that goes up in the mock-up. Goes on in the mock-up before we ever do the work in 324. And we do have lessons learned. That's the great thing about the mock-up. As I was saying, before we do any of the work in 324, for example, the remote excavator arm, before we installed that in 324, workers had a couple months to practice installing it at the mock-up. The engineers and planners had a chance to observe the workers, refine the work package, so that we had the best chance of success when we went to do it at the mock-up. And there's a final rehearsal that we always perform. In the case of installing the REA, workers donned full PPE, as seen in the picture on the right, before they went to perform that work in 324. And that gets them used to having to wear that equipment. They understand the visibility limitations. There's multiple pairs of gloves they're wearing, and they just need to get used to that and comfortable with that. So when they're comfortable, they say, we're good to go. And then management comes in, they watch them do those procedures, see if there's anything that needs improvement or could be fixed. And once management's comfortable that everything's good to go, we have a high chance of success, then we go execute in 324. And that is one of our major accomplishments this year. This is the installation of the remote excavator arm in 324. That was accomplished in November. Picture on the far left is as the workers were practicing for weeks, months, putting that in the mock-up, practicing installing it. And once everyone was comfortable and we were confident of success, the picture in the middle is the workers pushing the remote excavator arm into the airlock. And you can see the last picture, we now have that installed in 324, no issues installing it. And that is actively being used in the hot cell right now to size reduce some of the debris, and it'll be used to break up the grout, remove the debris embedded in the grout, and that'll assist with floor removal in the coming months.
Well, just to, I guess to add on to Ben, where you saw that excavator arm, the photo of it successfully mounted into B cell. I can tell you just as of yesterday, that arm was being used shearing up some of the debris that's in B cell that has to come out to get to the floor. So the project's going well, and every day we're making strides.
How was the contamination originally discovered?
In 2009, when they were preparing the 324 building for demolition, as they were clearing out old debris from the bottom of B cell, they discovered a hole in the stainless steel liner. And there were also some previous calculations done that showed that some contamination wasn't accounted for in the hot cell, so it had to have gone somewhere. So when they discovered the hole, it was suspected that contamination may have escaped through there, through the foundation of the facility and into the ground beneath. So in 2009, 16 geoprobes, essentially sensors, were fanned beneath B cell, and that's where they discovered the contamination, primarily cesium, strontium, from an old accident. Then in 2010, 2 more geoprobes were pushed much farther below the facility, and that confirmed that none of the contamination had reached groundwater.
So a year from today, what progress are we going to have, and what's the length of time to complete the project, assuming everything goes perfectly?
So a year from now, we'll have all of the equipment installed in B cell. We'll be removing the floor from B cell, and we'll be beginning the structural modifications which support the facility to prevent it from settling while we're excavating beneath the facility. So we're looking for that in 2020. We've got to finish our structural modifications first and proficiency training for the operators.
A lot of our greatest innovations come from confronting the greatest problems or conundrums. So are there any particular examples that you could cite where there's some technology innovation or things that maybe have never been done before or aren't done very often in this project?
So I will say the beauty of this is we're actually using a lot of off-the-shelf technology, so we're not doing too much innovation. That's going to, of course, increase the cost and complexity. We're using a John Deere remote excavator arm off the back of a backhoe, essentially, to go remove that contamination. There is some rad-hardened cameras and lights. You don't see those every day, so that is, you consider that some technology that we're using, yes. And the evolution of removing the floor from a HAZCAT-2 nuclear facility, excavating the soil out from beneath it, that's also that's not typical. But we are using typical or off-the-shelf equipment to get this done. Mike, did you have anything you want to add to that?
No, just to reiterate what Ben said is we are using as much as we can industry-proven off-the-shelf equipment. John Deere arms, we're using a Brock hydraulic power pack. Those are remote excavators. The diamond wire saws that we cut up the floor is an industrial diamond wire saw that you see used all over the country. Really, the innovation and challenge is figuring out how to be able to operate that equipment remotely inside extreme radiation environments. So off-the-shelf equipment, the innovation is installing and operating without being able to ever put your hands on it, which our team has done a great job of, and it's proven out so far.
You covered a little bit of this, but on the mock-up, how is that beneficial to the workers? Anything special on that?
Yeah, again, as was shown in the video and as Ben has kind of reiterated, that the radiation levels, both dose and contamination, are so high in that facility. It's not an area where you can go in and for the first time try this one-of-a-kind operation and have any chance of success. It's that mock-up, what that does is allows us to take our designs, go out, try them, and of course everything always looks perfect on paper. You always find small improvements. Inside that facility, once something goes in those hot cells, it becomes so contaminated that you can't fix it or make adjustments. So at the mock-up, we can go in, adjust the equipment, perfect it, train our workers, develop our procedures, such that as was shown and Ben said, when we go to put that first arm that went into the facility went flawless. And the only reason it did is because we were able to practice it and perfect it over and over again at the mock-up. And what that does is when you can go in and do it once, there's no rework. It's much safer on our workers. They just are getting a fraction of the dose and that they would have got if we'd have tried to do it for the first time in the facility.
Thank you.
Thank you for the presentation. My question to you this morning is, when will the soil excavations begin? And then the second question is, are there any possibilities of this contamination getting into the groundwater? What are the possibilities?
Okay. Soil excavation, we're looking at 2020 to begin that. We've got to remove the floor first. We have to finish installing the micro piles, which are essentially the stilts that support the facility. And we need to finish our readiness assessment, which verifies that the equipment, the facility, and the workers are ready to go. And then we'll begin our soil excavation in 2020. regarding is the possibility of migrating contaminants to groundwater. Currently, we do have the 2 geoprobes down there, which have not detected any migration to groundwater. And there will be some water application during this evolution, and a water usage analysis is being performed right now. And what that looks at is how much water do we anticipate supplying or putting into the hot cell during this activity, and what is that going to do to the contaminants below it. So we're going to model how that might move, and that's going to tell us what our limit is so that we're not impacting groundwater contamination levels, so that we're not exceeding those. So that is something we'll be paying very close attention to, because we don't want to resolve one problem to create another.
Good morning. What is your model predicting for the levels or the amounts of soil that you anticipate removing from the B cell?
Do you want to tackle that one, Mike?
As Ben mentioned, with the geoprobes that were pushed underneath the facility, it's showing the very high levels of contamination that have to be excavated remotely are in the 6 to 8 foot range. And as you saw in the kind of the cartoon picture, that tends to just channel around the perimeter of the facility or the floor B cell, where there is the expansion joint, about 2 foot either side. And so based on the approximately 80-foot perimeter, 6 to 8 feet deep, 4 feet wide, we're looking at around 2,500 to 3,000 cubic feet of soil that'll come out. And that the modeling is indicating that'll get us to the levels that then we can backfill, proceed with demolition, close out of the facility, and then tackle the waste site using conventional remediation techniques that have been used successfully over the past years at Hanford.
Real quick question. So 2020, when you're successful, it's no longer in existence. 324 is gone, but the machinery that you utilized to take care of the contaminants are contaminated themselves. So what's the process for disposing the machinery that you utilized to be successful in 324?
2020 is when we expect to start the soil excavation, and that could take some time, maybe up to a year. But for the equipment that is left in there, we did talk about moving the soil into the hot cells. That's going to be grouted into those. And we've got the choice at that time, is it cost effective and worth the potential dose to the workers to remove equipment, or can we also grout some of that equipment into B cell, which it senses a huge waste box, you could say. It's got 5 foot thick reinforced concrete walls, and you're not going to get dose through there really. So it's an evaluation of what is the safest, most cost-effective path forward for the project.
Thank you very much for your presentation. This facility and the waste that's under it is of great concern to our community because it's very close to our community. It's very close to the Columbia River. And we have been arguing for funding in Washington, D.C. for years. So it's very exciting to see where you're at and to see that you're really close to start removing the soil. What is your sense of the continued funding from Washington, D.C.? Are we good to go? Or is there any jeopardy that we might not have funding to complete this project?
That's yours, man.
Mm-hmm. For DOE, this is remediation of 324 is a priority, as we mentioned. Same with the stakeholders, the regulators. We believe that Congress also recognizes the necessity to deal with this facility. Right now, the contamination is under the foundation, so there isn't any driver that could mobilize it any further.
Let me add to my question. This is a Category 2 nuclear facility, and therefore there are water lines around the facility for fire suppression if there was a fire. And those water lines are as old as the building. So that's of concern to us, is that there is a potential for a water line leak that could move contamination.
Mm-hmm. So right now, due to the location of the contamination, being under the foundation and relatively close, 6 to 8, your highest contamination, 6 to 8 feet below the facility, you have a lot less likelihood of lateral migration of water that could force down the contamination. And we are right now digging on the side of the building because we do need to move the geoprobes that we're talking about. And whenever we're doing any sort of excavation around the fire lines that you're referring to, we do shut those off, and which they're off right now when we are doing the removal of the geoprobes, just in case a piece of heavy equipment could hit those, even though right now we have steel plates over them, over the lines, and ecology barricades in the way. So that is a relatively low risk. And in terms of remediating 324, it is a high priority for DOE, so we are pushing to get this done.
Thank you very much.
This contamination, as radiation decays, is there any potential for, or is there actually any decaying going on at the moment? And what are the possibilities of that going beyond the area that's contaminated right now, as far as the contamination and the radiation that's being, the activity is going on right now?
So to your first part of your question, cesium strontium, it's got about a 30-year half-life, so yes, it is decaying below the facility, which doesn't pose a threat. That's actually good news. It means the radiation levels are getting lower as every year goes by, which is less threat, and it makes open-air demolition easier when we get to that point. What was your second part of your question again?
What are the possibilities of that activity spreading beyond the area that it is currently?
So for the contamination to spread, you'd have to have some sort of driver, which would be water application. And since the foundation of the facility covers that and B cells relatively close to the middle, you're not going to have those drivers from the outside environment. I did mention during excavation there would be water application, but we're calculating our limits so that we do not drive our contamination down into the groundwater. So there will not be a risk posed by that. And Mike, did you have anything you wanted to tackle on that?
Well, I will add is that the cesium, the contamination that we do have underneath B cell, fortunately is not very mobile in soil. In our modeling that the water study that Ben mentioned, we're finalizing that right now, and it's showing that even with the minor amount of water that will be added to prevent the dust while we're excavating that so we don't load up the in-cell filters, that it will not cause any migration of concern with that cesium, because it does bind up well in the soil types that we have here at Hanford.
Well, I appreciate you guys coming down and answering some of these questions, because in many instances, people, because they're not knowledgeable, will have this anxiety of, well, what is really going on? But I think that this communication is very important, that we maintain it so that our communities will know that they are safe, that they are protected, and that cleanup is on the way, and that we can, be confident that we're going to go to a safer environment, and that they will be cleaned up someday. So thank you very much.
Thank you.
Thank you for joining us for another Hanford Communities Issue Briefing. I'm Sandy Monrian.
To find out how you can become more involved in this important regional issue, or to have a Hanford Community speaker talk to your organization, contact the Hanford Communities at 509-942-7348 or visit our website